Hello, students. We are getting ready to investigate our next step of our geology unit, and that is a look at earthquakes. Now, there's plenty of books that have been written, plenty of videos for you to feel free to watch on YouTube that do a very good job of describing how shock waves move through the earth. We know the effects they have on the surface. They can destroy buildings, they can cause landslides, they can damage human structures and civilization just as easily as they can cause destruction and damage in nature. Um, but a way of studying earthquakes themselves is it helps to understand where they come from, what are they really, and then how do they affect us? Those are the three key questions we'll be looking at in this unit that starts with this video, understanding what earthquakes truly are, those shock waves that travel through the ground. And then with the second part, we will investigate how they affect people, and you will build a structure of your own at home or wherever you happen to be, and then using the table, the surface that you're working at, you're going to simulate your own little earthquake and watch what happens to the structure you built. We'll get to that in the next video, but for now, first step, what are earthquakes really? Let's start with that. Okay. So, if you want to take notes during this time, obviously feel free, but pay close attention to how those shock waves move through the earth. And I don't just mean along the surface, I mean down through the earth as well. All right, ready? Let's go ahead and get started. Here we go. Um, when I say shock waves through the earth, I mean something deep underground. As you see right here in this image, something deep underlying. Maybe it's a fault line, a crack in the ground, right? And it's under pressure. This part of the ground is under pressure, and that part, right? And one of them is moving, pushing together, the other one is resisting, and they bind up together. Okay, they bind up and they're stuck, and then finally there's enough force, enough pressure, and it releases. And when that shock wave happens, it sends waves out through all different directions from wherever that stress was released, that epicenter, that source of those seismic waves. Now, that happened right here in Salt Lake City, and Magna, and they felt it clear down to Provo and up to Ogden and into the mountains. Um, in March of 2020, we all felt it, those who were here. So in a way, having had that experience, now we have something to connect it with. What we felt, this is what actually was happening down underground. Those shock waves coming through the earth from that point that released that pressure, and those shock waves moving in all directions. So, seismology is the study of seismic waves and ground waves as they move in all directions. And it may surprise you to learn there's more than just one kind of shock wave, because the earth moves in different ways when something like that happens. Part of it will get compressed and pushed. Part of it will get moved side to side. Part of it can get lifted and ripple. And we're going to explore all three of those right now. So, from the epicenter, that's the source of the earthquake, from wherever in the earth it begins, those shock waves go in all directions. The fastest waves are the first ones to arrive, the first ones we feel. They're moving fast through the ground. That's the push. Okay. And then after a bit, it could be the shear waves, the side to side waves. And then after a while, a little bit later, the surface waves, the L waves come along. Okay. They spread outward from that source, they propagate in all directions. And we have machines, handy little needle on paper, and then there's other machines as well that show us how intense was that earthquake. If that needle's going crazy on the paper, you know it was a very intense seismic event. But if it's barely rippling, either it was very mild, or maybe it's like a semi driving by on the street, and it's like, oh, there's some kind of little rumble, and then it's over. So, let's take a look down through the earth how these waves move. In this picture, you can see that the waves themselves pass down through the core of the planet itself, and they can be measured using those seismometers on the other side of the earth. And special stations that have this sensitive equipment, they're measuring these things all the time, okay? And they're always noticing movement somewhere in the world, and usually it's so minor, only the machine can pick it up. And a person sitting there in that location doesn't feel a thing. Right now, wherever you're sitting, there are tremors happening somewhere in the planet, on the other side of the world perhaps, and you don't feel them. But a machine in the room with you would twitch a little bit, and you're like, whoa, earthquakes are happening pretty much all the time. All right, let's take a look at the three kinds of waves. We can measure the kind that push, we can measure the kind that go side to side, those shear waves, and we can measure the ones that lift and drop, those surface waves. And I have a handy thing here to show you how they move. I've got a slinky. All right. So I've got a slinky, and I would like you to see the difference between a P wave, an S wave, and the surface waves. They're called L waves. Okay. All right. So watching the slinky now, I'm going to show you a P wave. Remember, P wave is a push. So wherever that piece of crust that was bound up against its neighbor and they're like in conflict, and finally something gets released, the first wave that goes out in all directions is the push. Observe. Watch the slinky in this video. Probably wasn't very pronounced. Let me try that again. It goes straight down. It's a push. It's a shock wave through the ground. Okay? So that's your first one, your fast-moving wave. Okay? And when you build using your household items and you simulate it at your table, that's going to be the first kind of shock wave that you simulate when you build a building to see how it withstands the earthquake. So again, P waves. The second one is called a shear wave, an S wave. Okay? It is the second one to arrive, and it moves like this. Side to side. We feel it vertically, but this slinky is good at showing it side to side. So again, the difference. Watch the difference. Push wave, very fast. Shear wave, a little bit slower. And the third one is an L wave. I'm going to show that in this slinky as a lift. It's a little bit more dramatic. This is the one that can cause a real load of damage on the surface. Check it out. So you see I lifted it, and that's your surface ripple. So to recap, P wave, S wave, and L wave. Those are the three differences that nature delivers every time there's an earthquake. All of those waves exist. Okay, so keep that in mind. Okay, as we go through and build your structure. And it's not just one kind of shaking in the earth. So we're not going to do just one kind of shaking when you create a structure at your table or on your hard surface. Okay. So take what we've observed, keep that in your mind. Okay, so this has been a short video describing seismic waves, how they move, and the order in which they arrive at your location, wherever you're feeling the tremor or the earthquake. Up next, our next video is going to be where we do the lab itself. And I'll walk you through how to investigate those seismic waves through the ground using a structure that you build yourself. So, in preparation for that, I'd like you to start up the next video. It's going to be 2.11, part 2 of this lab prep, and it'll walk you through how to do this. Gather some items around your house. Maybe it's some plastic cups, right? Maybe it's just a little box or some things that you can stack. It could be simple. It could be as simple as this. Or even better, if at your home you have some children's blocks, right? And you can build some kind of a structure. Obviously, now we have something with a little bit more design to it, right? And we can build something that we can really test when we give it those shockwaves. So, for now, feel free to gather some household items, okay? Whatever you happen to have, you can make it work, okay? And also your lab report. It's at number 2.12. I'll also attach it to 2.11, the next video in the series here. Print this out, or on a piece of paper, be ready to just write down all the blanks you fill in. You can do it on a normal piece of paper as well. Okay, so for now, this wraps up our first video. Go ahead and proceed to the next video, and let's get started.